Hello everyone, welcome to Atcoder's beginner contest 392. We are discussing the fourth problem of it, the D problem. So the problem statement states that there are n dices. The ith dice has ki faces. So I hope you have played with dice before. So this is a dice. Alright, so the dice has faces, right? So the faces. So every die has ki faces with numbers a of ai1, ai2 up to ai, ki written on them. When you roll this dice, each face appears with a probability of 1 by ki, right? So let's say a dice has 6 faces, 1, 2, 3, 4. I hope you have seen a normal dice before. So let's say this is the dice. Then the probability that every face comes once is 1 by 6, right? There are 6 faces in total and every face has a probability of 1, alright? So every face has a probability of 1 by 6. So that is what is written in the question. What we need to find is, just a sec. What we need to find is we must choose 2 dice, alright? So we are choosing 2 dice from n dice and we are rolling them. We need to find the maximum probability that the 2 dice show the same number. Alright, so this is the important question here. The 2 dice show the same number when the dice are chosen optimally. Alright, so let's take an example. These are the constraints. Let's take an example. Let's say these are these dice. Alright, the first die has 3 faces, 1, 2, 3, and the second die has 4 faces, 1, 2, 2, and 1. Alright, so what we need to find is the probability that 2 dice show the same number. Alright, dice show the same number. Alright, so in mathematics the probability that 2 dice show the same number is given as sum of all probabilities, sum of all multiplication of probabilities. Now what does it mean by multiplication of probabilities? Let's see. So let's see, these are the 2 dice. So the numbers that appear in the dice are 1, 2 and 3, right? In both the dice the numbers that are appearing are 1, 2 and 3. So we will find the probability that 1 is appearing on the same dice. Alright, the 1 is appearing on both dice at the same time. So the probability that 1 appears in the first dice is 1 by 3. Can I say it like that? There are 3 dices and the 1 is appearing one time, so the probability is 1 by 3. Multiply by the probability that the 1 appears in the second dice is 2 by 4. Can I say it like that? 2 by 4. Can I say 2 by 4? Why? Because 1 is appearing 2 times in the second dice and the total numbers are 4. Alright, so the total probability that 1 appears is 1 by 6. Am I correct? Right? 1, 2, and 3. Right? So the total probability that 1 appears is 1 by 6. Now same for 2. Alright. What is the probability that 2 appears in the first dice? Alright. So the probability that 2 appears is 1 by 3. In the first dice there are 3 numbers and 2 is appearing once. Alright. In the second dice 2 is appearing twice. So 2 by 4. Alright. So the probability that 2 appears is 1 by 6. Same. The probability for 3 appearing is, now let's see, in the first dice 3 is appearing 1 by 3 times, multiplied with in the second dice there is no 3, so can I say 0, right? 3 is not appearing any number of times, so the total probability that 3 appears in both dices is 0. Now you can also say it logically, as you can see 3 is not appearing in both the dices, so of course it will not be present when both dices are rolled simultaneously, right? So the probability for 3 is 0. Now what we will do is we will sum all of these probabilities together. So 1 by 6 plus 1 by 6 plus 0. So the total probability is 2 by 6, that is equal to 1 by 3. So the total probability for this 2 dices is 1 by 3. Now what we need to find is the maximum probability. I hope it is clear what do I mean when I say 2 dices. Alright, so this is the first dice and this is the second dice. Alright, so the total probability for these 2 dices having the same number is 1 by 3. Is that correct? Now we need to find the maximum probability among all the 2 dices. Alright, so let's say this is the first example. So as you can see, this is the first dice. The first dice has 3 faces, so these are the 3 faces. The second dice has 4 faces and these are the 4 faces. The third dice has 6 faces and these are the 6 faces. So if you look at the constraints very carefully, you will find that the value of n is 100, so means 10 squared, right? So the value of n is very small. So what we can do is we can use 2 loops to find the maximum number probability for 2 dices. Am I correct? So what we will do is, see, let's see. The first dice has numbers 1, 2 and 3. The second dice has 4 numbers 1, 2, 2 and 1. And the third dice has 6 numbers 1, 2, 3, 4, 5, 6. Right? So we are given 3 dices, right? So the value of n is 3. The first value that we have to input is k. What is k? The number of faces, right? This is what is k? Number of faces. So we will input k first, alright. Then we will input an array of size k, right? This is an array of size k. This is also an array of size k of 4 size, and this array is of size 6. Am I correct? Now, what we will do is we will use two for loops. And we will find probability in a of I and we will find probability in a of j, right? So how we will do it? So let's say the I index stands at this index, right? This is the 0 index, the first index and the second index. So let's say I stands here and j stands here. So what we will do is we will find probability, maximum probability using a of I and a of j. What is a of I? A of I is an array of size 3. Alright, so a of I is an array of size 3, right? This array. And a of j is also an array of size 4, right? So this is the array. Am I correct? Now we will find the maximum probability among these two. Now, what have we done? We have chosen numbers, right? So the numbers appearing in common are 1, 2 and 3. Like we have chosen all the numbers. Now what we will do is we will find the probability of 1 in the first array, right? Am I correct? The probability of 1 in the first array, this A wada array, you can say the first array. So the first array of probability of 1 into probability of 1 in the second array. Am I correct? We will find probability in the second array and we will find probability in the first array, and then we will multiply them. Same for 2, we will find probability of 2 in the first array multiply by probability of 2 in the second array. Am I correct? And same for the third one, we will find probability of the 3 in second array, first array, and probability of 3 in the second array. Am I correct? Now how do we find probability? So it is very simple. Probability of any numbers, can I say it like that? Total number of occurrences of that number divided by the size, total size. Am I correct? Like if we have to check the probability of 1 in this array, so what we will find is how many times 1 is appearing in the array. So 1 is appearing only one time. Now what is the total size of the array? The total size is 3. So the probability of 1 in this array is 3. So the probability of 1 is 1 by 3. Same here. What is the total number of occurrences of 1? So 1 is appearing 2 times. Am I correct? 1 is appearing 2 times. Am I correct? And the total size of the array is 4. So the total probability of 1 appearing in this array is 2 by 4. So the total probability is 2 by 4. And what we will do is we will multiply both of these. Am I correct? Right. This is what we are doing. Same for the second one. The total occurrences of 2 in this array is 1 and the total size of the array is 3. So the probability of first occurrence is 1 by 3. See? And the total probability of 2 occurring in this array is 2 is appearing 2 times and the total size is 4. So 2 by 4. So that 2 by 4. Correct? Total probability of 3 appearing in this array is 1 and total size is 3. So 1 by 3. Right? 1 by 3. And 3 is not appearing any number of times. So 0 by 4. Am I correct? 0 by 4. 3 is not appearing any number of times. So it is 0. And we will multiply all of them. And finally what we are doing is we are summing them up, right? So finally summation of all these multiplications, right? So we are summing all of these multiplications up, right? So finally we are summing this up, right? So how do we find the total occurrences of any number? So we will use a hash map, right? To find occurrences of any number, you will use a hash map, right? So as you can see from the code, this is the final answer. So I will make a solve function. I will pass a of I in it. I will pass a of j in it. What is a of I? A of I is an array. Let's say this is the array a of I. A of j is also an array. So 1, 2, 2, 1. This is the second array. I will pass the size of a of I. So a of I dot length or size, whatever, in whichever language you are using, you can use that one. So I'm also passing the size of it and I'm also passing the other size of it. So a of j dot length. And in this solve function, I will make 2 hash maps. Am I correct? I will make 2 hash maps. So 2 hash maps are made. And finally what we are doing is we are traversing for every hash map. So let's see. Let this hash map and this hash map. Let's call this the first hash map. And let's call this the second hash map. So in the first hash map, what we are doing is 1 is appearing 1 time, 2 is appearing 1 time, 3 is appearing 1 time. In the second hash map, 1 is appearing 2 times, 2 is appearing 2 times. Correct? 1 is appearing 2 times, 2 is appearing 2 times. Now, you can traverse in either of these arrays, right? So you can traverse in either of these hash maps. So what I will do is let's traverse here. So for 1, what we will do is I will find the probability of 1 in the first array multiplied with the probability of 1 in the second array, right? Probability of 1 in the first array and probability of 1 in the second array. Now for the second array 2, the number 2, I will find probability of 2 in the second array and the first array, and probability of 2 in the second array. Same for the third number, probability of 3 in the first array into probability of 3 in the second array, right? And we will sum all of these up. So we are also simultaneously finding the sum. It may seem complex right now, but as you will do the code, you will find it very, very, very simple. All right, so let's do the code for this. All right, so let's do the C++ code for it. So read the input format very well. So the input format states that we have to input the number n as input first. So let's make a number n. So we inputting n. Now we have an array which is of size n, right? So we will traverse for n times. So let's traverse for L times I equals 0 till I equals n, I plus plus. First what we have to input is we have to input a number k, right? So there is this number k, the size of the number of faces on the dice. What is k? Number of faces on the dice. This is k, right? Now we will traverse for k times, right? And we will input all of these dices, right? So we will traverse j equal to 0 till k times. And what we are doing is we are inputting a number x, let's say a number x, and let's store it in a temp vector. So let's say I have made a temp, and finally what we are doing is we are storing a dot pushback temp. So we are finally made an array, a 2D array named a, right? So this is the 2D array a of I. You can also do it like this, like you can make an 2D array of size n, and instead of using a temp variable, you can directly say a of I dot pushback x. So you don't have to do any of this. So we are pushing x into every a of I, right? So the first array would contain 1, 2, 3, the first 1D array, then the second 1D array would contain 1, 2, 2, 1, and the third 1D array would contain 1, 2, 3, 4, 5, 6. Am I correct? Now what we will do is the array has been made. Now we will traverse 2 times, right? So we will traverse 2 times using tool for loops. So we are traversing j equal to I plus 1 to j equal to n. Now what we will do is I will call a solve function, right? So I will make a solve function. I will pass a of I in it, I will pass a of j in it, and I will pass a of I dot size, and I will pass a of j dot size. So I made a solve function like this. Now what will this solve function return? This solve function will return the total probability. So the total probability would be a double, right? So total probability would be find out using solve function. So what is the total probability? The probability that the dices a of I and a of j show the same number. That is what you are finding, the total probability. And I will compare it with a maxi variable, right? So we are finding the maximum probability, right? So finding the maximum variable, and finally we will print maxi, right? So let's make a maxi here. So the total probability initially is 0, you can say it like 0, and we are comparing it with maxi, all right? So this is the maxi variable, all right? Now let's make this solve function, right? So what have I done for the solve function is I will make a function double solve. Now we are passing 2 arrays, right? So this is the first array named a, this is the second array named b, then we are inputting the first size, and we have the second size. You can name the variable as per as you want. I am using simple naming variables. Now what we will do is we will make 2 hash maps, right? So let's make an unordered hash map called first and unordered hash map called second. We will traverse in the first array and we will increase the frequency of it. So first hash map is made. We will traverse in the second array and we will increase the frequency of the second hash map. Now what we are doing is you can traverse in either of these arrays. That is what I said. You can traverse in either of these hash maps, right? So let's say we are traversing in the first hash map. So what we can do is we can traverse in the first hash map. Now let's find all the probabilities. All right, so let's say the occurrences of 1, right? Occurrences of, let's say a name variable x, it dot first, then a variable name y, then it dot second. What is x? The total occurrences of occurrences of it dot first in the first array and occurrences of it dot first in the second array in the B array. Can I say it like that? And this is the A array. So what I will do is I will find the occurrences of it dot first, right, in the A array. So it dot first is actually it dot second. Can I say it like that? Or you can say it like the occurrences can be found out using this one, right? Occurrences of it dot first in the first array, and for B it is occurrences of it dot first in the second array. Now what I will do is I will find, we will add sum of it in what? So I am dividing x by what? First size, and y divided by second size, right? Total occurrences divided by size of it, right? Then total occurrences divided by size of it, all right? And finally I am returning sum. That's it. This is the simple function of it. Let's make a double sum variable. Right, that's it. So what I've done is, just a sec. I found the occurrences of first in the it of first in the first array, A array, and occurrences of it dot first in the second array, right, the B array. Now total occurrences divided by size of it, then total occurrences divided by the size of it will give us the probability of this number, right? So this is the probability, right? So this is the probability of getting the same number, right? Then we are adding it in sum, and finally we are returning sum. So this is the solve function of it. Now let's make quickly double and 1.0. So we are converting everything into a double, right? So we must multiply it by 1.0, right? So this would convert it into double, and then we are finally returning sum. Now let's run this. So we are finding the maximum probability out of every dices. Okay, so it is slow quite here. Alright, so as you can see, it is getting the correct answer, but it is not giving answer to the proper precision. So what we will do is, we will use the fixed variable, fixed keyword in C++. So set precision, and the number of precision it put is up to 15. So I am setting precision up to 15. Now let's run this. So it will set precision up to 15, and then finally it will get accepted. So as you can see, all the test case got passed. Now let's submit this question. So I'll submit it in C++ here. So submit. Now let's see. So as you can see, my C++ code got accepted. Now I can optimize this solution a little bit, right? So how do I optimize it? Okay, like instead of traversing in the first array itself, I can traverse in whichever hash map is the smallest one. Like whichever hash map is the smallest one, I can traverse in it now. Smallest one, we can iterate over it, iterate over that array, over that hash map. So instead of, I will compare the size of it, right? So this is the first optimization. Okay, if the first size, if the first hash map has a lesser size than the second hash map, right? So instead of traversing in the second hash map, I can traverse in the first hash map itself, right? And otherwise I will traverse in the second hash map. So I will traverse in the second hash map. Same thing, we will find occurrences of it of first in the first hash map, right? So occurrences of it dot first in the A array, and occurrences of it dot first in the B array, and finally we are editing in sum, alright, and then finally we are returning sum. So this can be a little bit of optimization itself, right? Instead of traversing in any of the arrays, we can compare the size of it. Like if the first hash map is of the smallest one, then we can iterate over that hash map now. So you can also use it like this. So this code bit also gets submitted. So let's submit this one. Right, this is a little bit of optimization in it. So you can also do it like this. So as you can see, this approach also got submitted. Now let's do the Java code for the same. Alright, so we are doing the Java approach. Please read the input format variables. We are inputting n first. So let's do the Java code. So we are inputting n first. So I say dot next int. This is the n variable. Now what we are doing is we are traversing n times, and first of all we are inputting the variable k, the size of the dice, right? So we are traversing for n times, int I0 till in I plus plus. First of all we are inputting a variable named k. What is k? What is k? The size of the dice, right? The number of faces on that, the number of faces on the ith dice, this is k. Then we will traverse for k times, and we will input a variable x, right? So int x equal to sa dot next int. Now instead of using a 2D array like normal, I would say I would use a 2D array list, right? So let's make an array list of array list. So let's make an array list of array list. So I have made an array list of array list of type integer, right? So let's make an array list A, new array list. So this is the array list, and the array list size would be n, right? So let's make an 1D array list, temp to new array list, and I will store x in temp, and finally I will add temp in x. So temp is a 1D array list, right? So this is a 1D array list, and this A is a 2D array list, and I will add temp in A. So I am adding a 1D array list to a 2D array list, right? So array lists are made. Now what we are doing is we are finding the maximum probability, right? So we are finding the maximum probability. Let's make a maximum variable. Now I will traverse using 2 for loops. So I will traverse in 2 for loops, right? And j equal to 0, j less than j I plus 1, j less than n. So what I mean doing is I will find the maximum probability, right? So finding the probability of having the same number on dices I and j, right? So I will find the probability that dices I and j have the same probability. So I will make a solve function. I will pass a of I in it, I will pass a of j in it, I will pass the length of the first dice and the length of the second dice, right? So the length of the second dice, that is what I have shown you now in the code. Okay, let's say a of I is this dice and a of j is this dice, 1 2 2 1. I will also pass the length of it, and I also pass the length of this dice, right? And for both of these dices, I will find the probability that two numbers are appearing the same number of times, right? So let's do the code for that. So let's make this solve function, right? So what the solve function will give us, this will give us the total probability, right? So I will save the total probability and I will compare it with the maxi variable, right? So maxi comma total probability, right? So I will compare total probability with the maxi variable, and finally I will print the maxi variable, right? Simple as that. So this is the solve function, that is what we need to make. Alright, so let's make this solve function. So I will make a solve function. Now a of I is an array list, right? So a of I is an array list. So a of I is an array list of integer. So this is the first array list named A, then the second array list named B, right? So array list of integer B. Then I also have the first size, so the first size, and I also have the second size, right? So this is what I have. I have an array list A, I have an array list B, then I also have the first size and I also have the second size. The type of this function is a double, right? So the type of this function is a double, right? So this solve function. Now it is still giving me errors, some errors. It is not length, na? It is size, sorry. So array list doesn't have a length function, it has a size function always, and it is not a of I. So in Java we have to use a.getI. So instead of using a of I, we must use a of get I, right? So common mistake there, and get j, right? Am I correct? A of get I is an array list, a of get j is also an array list. All of these are 1D array lists, right? So 1D array list. Now how do we find 1D array list? So I first will make two hash maps, right? So I will make a hash map of integer called first, and I will make a hash map called second. The first hash map will store the frequency of all numbers in the first array list, right? So the frequency of faces in the A array list and frequency of faces in the B array list, right? B array list, right? So we have made two hash maps. So let's traverse in the first array. So I will traverse in the first array I plus plus, and I will add it in the first hash map. So first hash map dot add, I will add a dot get I if it is present in it. So if it is present in the first hash map, I will add +1. So we are increasing the frequency, and if it is not present, I will put a 0 there. I hope you know how to use frequency in a hash map. Then same for the second hash map, I will traverse in the second hash map and I will put it in the second hash map. Now what I will do is I will traverse in either of these arrays, right? So as I've said in the code, you can traverse in the first array itself, you are traversing just faces of it. So let's say we are traversing in the first hash map. So for every key in first dot key set, right? So we are traversing in the first key set, right? So we will find the occurrences of key. Occurrences 1 means first dot get key, right? So we are finding the occurrences in the first, in the A array, and the occurrences 2 is second dot get key, that is the occurrences in the second array, where D array. But let's say if it is not present, so we will use a get or default function. So if the key is not present, we will occurrences are 0. Now total probability can be find out is, how do we find probability? We are dividing occurrences divided by size of it, the first size, and we are multiplying it with occurrences 2 divided by second size. Am I correct? The probability of having the same number on dice is I and j, right? Correct? Right, that is what we are doing now. We are probability of A. How do we find probability of A, right? So we are dividing probability by total occurrences divided by size of it now. So we are finding the total occurrences and dividing by the size of it. So occurrence 1 is the occurrences in the first array and we are dividing it by the size. Then occurrence 2 divided by the size of it, right? And we are adding the total probability in the sum number, and we are finally adding the returning the sum variable, right? So let's make a sum variable there. Double sum equals 0. So this sum variable, and we are summing up all the probabilities, right? So we are summing all the probabilities, right? Correct. Now what we need to find is, we need to keep a little bit things in check. So multiply by 1.0 to convert it into double, right? So you are converting everything into double, so you need to multiply it by 1.0, otherwise it will not get converted to double, right? So we are converting it into double and we are adding it into sum. Now let's run this. Yeah, so as you can see, the code got accepted, but you can also do one thing. You can set precision to it. So instead of using println, you can use a printf statement. So I will print it up to 15 decimal places of precision. So I have written 0.0.15f. So this will print up to precision of 15 digits, right? So 15 digits, right? So this is what we are doing. Now let's run this. So 15 digit precision is enough for this. It is saying something wrong in the alright, so I think this 0 is not supposed to be there. Let's run this one. Yeah, so as you can see, the test kit got submitted. Now let's submit this approach. So I'll submit it here, Java. Alright, so as you can see, the code got submitted. Now you can also optimize this solution a little bit. So what I have done is, I have traversed in the first key set, right? So I have traversed in the first hash map. So what did I say? You can traverse in either of the hash map. You can either traverse in the first hash map, so I will traverse in the keys of it, or you can traverse in the second hash map. So logically, if I am doing the optimal approach, so I will traverse in the hash map which has a lesser size. So I will traverse in this second hash map now, because this second hash map has a lesser size. So instead of traversing in the first hash map only, what I will do is I will compare. Okay, if the first hash map has a size which is lesser than the second hash map, then I will traverse in the first hash map only. So I will traverse in the first hash map. Otherwise, I will traverse in the second hash map. So same thing here. So otherwise, I will traverse in the second hash map. So I will traverse in the second hash map. And same thing here, get or default key, otherwise 0. Right. So here you can just write get here. Get key. Right. So instead of traversing in the first hash map only, I will either traverse in the second hash map or the first hash map, depending on the size of the hash maps, right? So this approach will also work. Now this is a little bit of optimization on my side, so you can also use this one. Okay. So as you can see, this approach is also fine. Now let's also submit this one just for confirmation. So let's submit this one. Let's see. So as you can see, the code also got submitted. Alright, so the total time complexity of this code would be O of n cube, right? So both of these codes would be O of n cube, because we are traversing in the I loop, then in the j loop, and we are also finding the hash map of it, right? So this traversal takes O of n time, this traversal also takes O of n time, and making a hash map also takes a time of O of n. So all of these would combine give a time complexity of O of n cube. And if you look at the constraints of the questions are very small, 10 square, it is 100 only. So time complexity of n cube would be 10 raised to 6. This would get submitted very easily. So this was an easy question on, I think so, for a D problem. This was a fairly simple question. And the space complexity of this approach would be O of max size of any dice. Can I say it like that? Of any dice. Like if I'm using a hash map, what is the maximum size of a hash map? It would be the maximum size of any dice, right? So the maximum size of any dice. Let's say this dice has 6 faces and this dice has 4 faces. So which size would be greater? This size would be greater, na? Because this dice has 6 faces. Yeah. So considering the dice have faces up to 10 raised to 5, right? So k of I and a of ij is so like a maximum dice face can be 100, right? So O of space B can be O of max size of any dice, right? So this is the time and space complexity. I'll explain the code once more. Let's say these are the two dices. So these are the two dices, 1 2 3 2 1, right? So these are the two dices. I need to find the maximum the total probability, right? So the total probability of two dices of two numbers having the same probability, same occurrence, right? Same occurrence. So let's say the one number is appearing in both the dices. So what I will find is the probability of 1 in the first array. So 1 is appearing 1 times in the first array and 1 is appearing 2 times in the second array. So 2 by 5. Am I correct? 1 is appearing 1 time in the first array and 2 times in the second array. For 2, 2 is appearing 1 time in the first array and 2 times in the second array. Now for 3, 3 is appearing 1 time in the first array and 1 time in the second array. Now, so I am multiplying all of them. So let's see, 2 by 15, this is 2 by 15 and this is 1 by 15. Is it correct? Now what I will do is I will sum all of these up. So the total probability of two numbers having the same occurrence in both the dices is 5 by 15. That is equal to 1 by 3. So for two dices, the probability, the total answer for this would be 1 by 3. Correct? Now we are finding we are doing this for every possible two dices, right? So we are traversing, that's why we are using two loops, I and J. Because we are doing this for every dice now. We are doing this for every dice and we are comparing it with the maxi variable. So we are comparing the maximum probability. That's why we are using two loops. So the two loops would take off n square time and all of these code, all of this multiplication would take another n cube, n times. So the total time complexity, that's why is a O of n cube. Am I correct? Right? So I hope the approach and the code is simple enough. Right? I made it simple so a beginner can understand it. This was a fairly good contest. I hope you learned a lot from it and I will see you in the next contest. Till then, keep learning. Take care. Bye-bye.